Hey guys, I hope this video finds you well. Now, sometimes we're going to take videos like this and there are going to be pretty much the lecture for the day. What I need you to do is make sure that you take your Cornell notes and that you're taking notes all throughout the video, all right? If you feel the need to stop the video to write down some of these notes, that is totally fine. I'm okay with that. However, when we are in class, I will give you a specific amount of time to take your notes. So just be cautious of that, all right? This lecture is going to be about environmental changes, and here says changes in population size due to various environmental factors. We're going to learn about what environmental factors are and how those factors are going to affect a population. And you should remember from from levels of organizations, what a population is, and now we're going to learn how a population is affected by some factors. All right, so let me see if I can get this to work properly. There it goes. All right, so I'm going to show you this graph, and this graph shows you the world population over the last probably 2,000 years or so, and this is in billions of people. And my question to you is, how many people do you think that the earth can sustain? Now, many of you might be thinking, and let me see if I can get this to work. Many of you might be thinking that could probably just keep going up and up and up and up and up and up and up to who knows how many billion people in the planet. Yet some of you might think that there's going to be some type of, I don't know, maybe like some type of apocalypse or something, a zombie apocalypse, and the entire population eventually just going to drop down. But what is most likely to happen is that eventually the population is going to reach what we call a carrying capacity. All right, and we're going to learn about what that carrying capacity is today. All right. These are the objectives. This is the way that the set of text puts it. Recognize that a long-term survival of species is dependent on changing resource bases that are limited. What I want you to do is write an essential question by making up a question out of this statement right here, the language objective. It says, describe how environmental changes can impact ecosystem stability. Okay, so if you want to write that into a question, you can just put, can I describe how environmental changes impact ecosystem stability? All right. So first thing is population growth. The changes in a population size, or how much the population is growing over a period of time, can be given uh, or can be affected by several things. The first one is birth rate, and birth rate is simply just the number of organisms that are born within a population over a certain amount of time. And this is obviously going to cause an increase in the population over time. The other thing is that is going to cause a change in the population is mortality. And this is how many organisms die within a specific given time. So obviously this is going to cause a decrease in the population. Besides birth and death rates, there are other factors that can also cause the population to grow or the population to decrease. And we want to see what those factors are in the next slides. So the first thing that we see as one of those factors is resources. There are many resources like water, shelter, food, amount of space available, how many other um, organisms of the same species there are to be able to mate and things like that. So all of these things are going to be resources that will be limited to a specific group of organisms or to a population as a whole. So organisms will often be competing for these resources to be able to survive. And this is just an example, of the panda bear. So if the panda bears, obviously they eat bamboo for a living, and in recent years we got to know that because of deforestation, the panda bear did not have enough resources, did not have enough food, or there was not enough bamboo for them to eat. So that we experienced a decrease in the population. But now the scientists are on top of this. We do not longer consider the panda bear to be endangered, and that's why it is so important to understand that sometimes these resources are going to affect the size of a population. So a limited resource base can affect the long-term survival of the species, thus affecting the population growth. All right, so just keep that in mind and make sure that you write some of those notes. Limiting factors, we're going to learn about two different types of limiting factors. A limiting factor is just a resource that has the ability to limit the population growth. Um, and there's two types of them, like I said. The first one is a density dependent limiting factor. All right, a density dependent. So what that means is that it will depend on the size of the population. These factors are dependent on the size of a population. So an example of that will be if there's an increase in the pandas, will mean that the bamboos has a chance of running out. So if the population is increasing, that means that there's going to be less and less and less bamboo. Um, and there can be any other type of examples, like for example a space. If there's too many pandas, well, space is going to become limited, so the population is not going to be able to grow anymore. Same goes for water. Too many pandas, that means that the population is bigger, uh, then water is going to be a lot difficult to get, a lot more difficult to get for the panda. So these are factors that are dependent on how the population is growing. Okay. The second one is a density independent limiting factor. So these are factors that do not depend on the size of the population. Regardless of the size of the population, there's going to be some factors, and that's why we call them density independent. They doesn't matter about how large the population is. Now, an example of that would be like a tsunami. Let's say that a tsunami comes in and kills a large portion of the pandas that were in a specific population. Well, it doesn't matter if there were 20 pandas or 300 pandas before the tsunami comes in. You are more than guaranteed that a lot of the pandas are going to die off. So the density independent limiting factor just does not care about the size of the population. Some other examples, and oops, let me go back there. Some other examples are like climate change, and we're going to see some examples like polar bears and things and other animals that are affected by this. Weather, um, then sometimes some other natural disasters, and even human activity can be can affect the population size, can be a factor that affects population size for specific organisms due to deforestation and other things. So at the beginning, I told you guys about carrying capacity. Well, the carrying capacity is just the maximum amount of organisms that a habitat can sustain. So whatever amount of resources you have, then your carrying capacity will be at about that specific number of organisms, or is going to be able to sustain that specific number of organisms. Um, so back to the example of the panda bears. Once the panda bear population reaches a certain size, um, it's going to reach its carrying capacity, or the maximum number of pandas that the environment can sustain, due to the fact that, well, food will become a lot less difficult for them to get. So that's what carrying capacity is. It's just the maximum number of organisms that a specific um, environment can sustain. So what are some things that are going to affect this? Well, hunting, fishing, predation, these are all things that we humans do to sometimes affect the carrying capacity of a specific population. So in the case of deer, for example, sometimes there's a reason why we have deer hunting season. And the reason for that is specific season where there's a lot of deer in the population, well, they allow humans to go out and hunt some of these deer. That way, we can reduce the size of the population a little bit, and we don't see a lot of the resources like the grass and all of those other things becoming scarce for the deer. So there are many other things like like I said, fishing is one of those. Um, there's fishing seasons, some seasons that you can catch salmon, some seasons you can't catch salmon. Um, Same goes for tuna fish and many other different organisms that you can hunt. And that is just so that we can keep it at that carrying capacity. So I have this chart right here. I do believe that you do not have a copy of these in your notes. Um, but this is kind of like an organizational type of chart, and it's going to allow you to uh, sort of put everything in perspective. I have it here completed for you guys. So population growth will be controlled by the carrying capacity. Again, carrying capacity, top number of organisms that the environment can sustain. So the size of the population, or how much the population growth, will be controlled by that carrying capacity, and that is maintained by some factors. That's going to always be maintained by some factors, which results in a stabilization of the population. So again, once you reach that cap, that carrying capacity, that means that okay, this is your pretty much the environment reaches a stability for that specific population. So some of the things that are limiting factors, I have several examples here. So make sure that you write at least 4 or 5 of these examples. I believe you have space for all 6 of them. So make sure that you write down those examples of limiting factors. Remember, some of them are going to be density dependent. Some others are going to be density independent, right? So for example, things like the lack of space, the lack of food, those are the disease. Those are going to be density dependent limiting factors. All right, the availability of water, that's going to be density dependent as well. But if there's like a hurricane or tsunami that is going to completely destroy the size of the population, then that's going to be a density independent limiting factor. If we put it on a table type of information here, when you see a specific graph and you're given a graph like this, you're going to see obviously the line of the size of the population increasing over time. You know that at some point the population will reach the cap. There's no more resources that the population can sustain, or that the population can get their hands on. So the population will start reaching its carrying capacity, and this is kind of like what graphs of populations usually tend to look like in most cases. So you have to remember what these uh, lines and points here mean, and have them right here for you. So in your notes, make sure that you write these things down. The carrying capacity is going to be that point where the population is going to reach its maximum number of organisms, and that's where it can be sustainable. After that, some point it reached here, but it keeps going down because it can sustain no longer anymore. Then limiting factors obviously are going to come in play when this happens. This sometimes we call a population boom whenever you see that that increase in the size of a population. Um, and obviously the population is all going to be stabilized once it reaches that carrying capacity. Now what we're going to do, we're going to do a lab, and hopefully we have time at the end of the class to complete this lab. So if you had enough time to finish this video, make sure that you take your notes. If you need to stop the video at certain points, again, go back and finish your notes. If you didn't finish during class, you're going to have to spend a little bit of time at home to finish these notes, but please make sure that you have these notes completed. All right, guys? So thank you very much for your time, and I will see you on the next video.